Hello everyone, in this video I am going to be discussing about building recommendation systems, concepts and principles. So what are recommendation systems? Recommendation systems are a fundamental part of modern e-commerce and entertainment platforms. They leverage user data and sophisticated algorithms to suggest relevant products, services or content, enhancing user experience and driving engagement. Now, let's talk about the fundamental concepts in recommendation systems. So, recommendation systems are built upon a foundation of key concepts which includes user profiling, item representation, similarity measures, and ranking algorithms. These concepts enable the systems to understand user preferences and predict their for future behavior. First one is user profiling. So user profiling involves creating a detailed profile of each user by collecting and analyzing their past interactions and demographic and preferences. So its components includes past interactions, then demographics, preferences, and then the second one is item representation. Now item representation involves describing items such as products, movies or articles using features and attributes that capture their essential characteristics. The third one is similarity measures. Now similarity measures are metrics that are used to define or quantify how similar two users or two items are. Now there are two types, user-user similarity, and then the other one is item-item similarity. So the common metrics for this is cosine similarity, Jacquard similarity. These two are used for the similarity measures. Then the fourth one is ranking algorithms. Ranking algorithms determine the order in which recommended items are represented to the user based on relevance and predicted interest. These components include relevant scores or the sorting mechanisms and the common algorithms, collaborative filtering, content-based filtering, hybrid approaches. These are the fundamental concepts that work together to form the backbone of recommendation systems. So we are going to look at the types of recommendation systems. Recommendation systems can be broadly classified into three categories: collaborative filtering, content-based filtering, and hybrid approaches. So collaborative filtering recommends items based on preferences of similar users. For example, user A has a preference over something and user B has similar preferences, so user B will also be recommended the similar items. Then we have content based filtering, where items are recommended based on the user's past interactions with similar items. For example, purchase history or watch history. If a user has liked something before, then that will be recommended to him or her again. YouTube does that quite a lot with its watch history. Amazon does it with its product purchases, previous product purchases. Then we have hybrid approaches. It combines the strengths of both of the previous filtering approaches that we have talked about, collaborative and content-based filtering, and provides the best recommendation. Moving on to data sources and collection. Data is the lifeblood of recommendation systems, which provides them necessary information to generate personalized recommendations. The recommendation systems rely on a vast amount of data to function effectively. These data sources include user interactions, demographics, purchase history, and external information. So under user interactions, data includes clicks, purchases, or ratings and watch times. Then under demographics, we have information about the person's age, location, gender, and other relevant characteristics. Then purchase history of the person. This includes records of the past purchases and the transactions that have been made by the user. Then we have external information. This includes data from social media, reviews, and other sources that provides insights into the preferences of the user. Now moving on to feature engineering. Feature engineering is a crucial step in building the effective recommendation system. It involves data cleaning, where we remove the noise and inconsistencies from data, feature extraction, where we derive the relevant features that are required from the raw data, then feature transformation. We transform the features into a suitable format for the algorithms to proceed further. Then feature selection. We choose the most important features for the model. Then we have collaborative filtering techniques, where we rely on assumptions that users who have similar tastes will also like similar items. For example, user-based filtering, where we recommend items based on the preferences of similar users. We have item-based collaborative filtering, where we recommend items based on the similarity of items previously liked by the user. Then we have matrix factorizations, where it is a technique to decompose user-item interactions and factors capturing user and item characteristics. Content-based filtering approaches. Content-based filtering is a recommendation system approach that relies on features of items and the preferences of users to generate recommendations. Here are the primary approaches used in content-based filtering. First, feature representation. This process of describing items using a set of attributes or features. For example, for movies, features could include genre of the movie, director, cast, and keywords. Then we have similarity calculation, the process of measuring how similar items are to each other or to a user's profile. For example, calculating the cosine similarity between a user's profile vector and an item's feature vector to determine how closely they match. Then we have keyword based filtering, a simple content based filtering approach that uses keywords to represent items and match them to user preferences. For example, recommending articles to the users based on the presence of common keywords in the articles and the user's reading history. Hybrid recommendation systems. Hybrid recommendation models combine the strength of both collaborative as well as content-based filtering approaches, leveraging the complementary advantages of both the techniques. This helps in improving the accuracy, enhancing prediction accuracy by combining different sources of information, reducing the cold start problem, mitigating the challenge of recommending items to new users with limited interaction data, and third, increased diversity, generating a wider range of recommendations by leveraging both content as well as collaborative based filtering approaches. Evaluating metrics and benchmarking. Evaluating and benchmarking recommendation systems are critical to understand their performance, comparing different algorithms, and ensuring that they meet the needs and business goals. So here are the key evaluation metrics and benchmarking approaches in recommendation system. The first one is precision. Precision is the percentage of recommendation items that are relevant to the user. Second, recall, the percentage of the relevant items that are recommended. Third, we have F1 score. It is the harmonic mean of precision and recall, meaning that it provides a balanced measure of performance based on both the methods, evaluation methods, which have been above called. Then we have mean average mapping. It is a metric that considers the order of recommendations and reward systems that prioritize relevant items at the top. Challenges and future trends. So recommendation systems face challenges such as data sparsity, cold start problems, and the need to address ethical considerations like biases and privacy. So data sparsity. Data sparsity in recommendation systems often deals with sparse data where users may have interacted only once with a small fraction of available items. This makes it challenging to accurately predict preferences. Then we have cold start problems. These occurs when new items or users have limited or no historical data available for recommendations. This makes it difficult to provide relevant suggestions until enough data is gathered. Then we have ethical concerns, bias and privacy. Recommendation systems must address biases in data and algorithms that can lead to unfair recommendations. Additionally, ensuring users' privacy while leveraging personal data for recommendation is crucial. Then we have transparency. It's important for users to know how their data is being used and how recommendations are generated. Then we have integration of AI and machine learning. AI techniques, recommendation systems leverage various AI and machine learning techniques such as collaborative filtering, content-based filtering, and more recently, deep learning approaches. Then integration. These techniques are integrated into large systems that handle data processing, real-time updates, and user interfaces, creating complex architectures that optimize recommendation quality and responsiveness. With this, we come to the end of the presentation. I would like to thank you for watching the video.